Welcome to Path to CitusCon, the podcast for developers who love Postgres, where we discuss the human side of open source databases, Postgres, of course, and the many PG extensions. Thank you to the team at Microsoft for sponsoring this community conversation about Postgres. I'm one of your hosts, Claire Giordano.
And I'm Pino De Candia. Today's topic is my journey into Postgres benchmarking. I have the pleasure of introducing Jelta Fenemanio. Jelta is a principal engineer at Microsoft, works on the Citus extension that distributes Postgres, and the managed service Azure Cosmos DB for PostgreSQL. Jelta is also a PG Bouncer maintainer, a sporadic PostgreSQL contributor. He's based in the Netherlands and did a master's in systems and network engineering from the University of Amsterdam. Jelta, welcome.
Hi, happy to be here.
And I have the pleasure of introducing Marco Slot. Marco used to work for Citus Data and then Microsoft for many years. So he spent years working on and thinking about, dreaming about Citus and distributed Postgres. Marco earned his PhD in distributed systems at Trinity College Dublin, and he once worked at AWS on CloudFront and now works at Crunchy Data, also based in the Netherlands. Welcome, Marco.
Yeah, thank you very much. Good to be back on this podcast, my second appearance.
That's right. You were on the very first episode along with Simon Willison. You were both keynoters for last year's CitusCon virtual event for Postgres. And yeah, it was awesome. You helped us pave the way to create this thing.
Yeah. No, it's a great platform. I really enjoyed the conversation then back with Simon about like working in public and open source. So if anyone's interested, I recommend you should watch. You should listen to all the podcasts. They're all pretty good. I mean, the lineup is amazing.
One of the things we do is we put show notes when we publish the podcast, so we'll be sure to drop a link to the episode with you and Simon into those notes. Okay. The topic today, though, is my journey into Postgres benchmarking or database benchmarking. And we have so many questions about why, when, and how both of you skilled up on performance benchmarking and how it's been useful to you in your work on Postgres and your work on Citus. So I kind of want to start with your personal stories, and we'd like to ask each of you the same question. Can you tell us a story about your very first performance benchmarking experience? Even if you were 18 years old, how did you first get your feet wet?
So I can start. So in university, at some point I did some benchmarking of, I don't even remember. I think it was MySQL, because that was somehow the easiest to run the benchmark on. And it was comparing containers and microkernels performance between them to see if microkernels, they're like sort of like containers, but they run directly on the hypervisor, and supposedly they're much faster. So I wanted to find out if that was actually true. And at least the benchmark I found on the internet that I ran, that was quite a bit faster for the for the microkernels than in Docker. So that was that was quite I guess that's my story.
Was this an assignment that everybody in class had to do, and where the syllabus clearly spec'd out like where to find the tools and what to use and what to do? Or was this just you being curious?
No, this was like the assignment was to sort of do. We had to do some sort of tiny research thing, but we could sort of choose something ourselves. So I came up with this together with another student.
Cool.
I have to
Marco,
ask, does anyone run databases in microkernels?
I don't know of anyone that does, but maybe it's a good idea. Yeah, I think it was even faster than running it on on a VM.
Sure.
because you sort of remove the whole. The idea is that you remove the whole system call stuff because you only have one process. Basically, MySQL or Postgres becomes the kernel, which is very strange, and hard to debug because logs, where do they go? How do you? All your normal debugging stuff goes away.
Maybe we should do another episode on all the places you can run Postgres, and we'll see if microkernels come in at that point.
Sounds like a good plan.
Could be a long episode.
Yes.
Okay, Marco, what about you?
I've good experience. I have fun memories of hacking microkernels at the VU where they were building Minix 3 at the time. But my benchmarking story starts at Amazon in 2008 when I joined the CloudFront team, which was still pre-launch at the time, and I joined as the intern. And being the intern, of course, I had to do benchmarks. And because we hadn't launched yet, we had bought a bunch of servers around the world, but we weren't taking significant traffic. So the question was like, what's our actual capacity like once we start getting some customers? I mean, at the time we were using Squid as the web server, which is this ancient piece of software. And then also the benchmarking tool is called Polygraph. I don't know if it still exists, but basically it simulates kind of web traffic, and so you can point that at a web cache and then see kind of how well it does and like how hard you can push it. But I was kind of doing this, and I was like, the benchmark has many different parameters in terms of request size and the distribution, or is it a big uniform distribution of every key, every URL gets requested the same amount of time, or is it more Zipfian? And we realized like I had no idea what the traffic was going to look like once we were actually starting to get customers. So then I started diving much deeper into the system and kind of using the benchmarks more to understand like the low level details of like how much effort do we need to spend for a particular type of request. So basically creating a model of what are the variables of the request that matter, and like what is the expected amount of work that needs to be done. And that way we could actually get a pretty good understanding of our utilization and our capacity once we went live. And I guess that work sort of ended up buying me a sort of remote part-time position at Amazon when I was doing a PhD, which was quite unusual at the time. And then the fact that I was a remote part-time employee, when like talking to the Citus Data founders, they were like, "Whoa, no one has that. We should hire this guy." So it was actually that benchmarking work was a quite important moment in my early career. And then when it came to Citus Data, of course, the first thing I had to do was benchmarking. So we ran these TPCH benchmarks on Citus at the time. This was earlier days, a different time when distributed like large-scale analytical SQL systems were kind of in their infancy. And Citus was actually pretty early in being able to do like large-scale distributed joins. So we kind of wanted to evaluate that, and so we got a good understanding out of the system. But we also found like a lot of limitations and kind of architectural performance issues that we knew would take a very long time to address. So I think from that point onwards, we started veering away a little bit from like targeting the type of data warehousing workloads that TPCH kind of simulates, and more into other types of workloads like software as a service and multi-tenancy and real-time analytics. So that was also quite interesting work. And then later in Citus, we started getting more into kind of transactional benchmarks. And then, Yelta, I guess, also has worked a lot on those.
You both have touched on, the different reasons people run performance benchmarks, right? I mean, Yelta's example was like the canonical case of comparative performance benchmarking, right? Wanting to do a bake off, if you will, and understand like which one of these performs better. And then, but what you're talking about is like understanding the utilization and the capacity and the costs and what's performing well and what's not well just within a particular thing. Like in your case, more recently it was Citus. And that literally caused a shift in the go-to-market strategy from data warehouses to SaaS applications and other types of workloads, which I think is fascinating. Like it just shows you how important understanding performance is.
Yeah, I mean it's an incredibly tedious thing to do. I don't like benchmarking, but it's also often one of the highest impact things you can do if you kind of well, I kind of want to say if you manage to answer the question that you're trying to answer, though very often the question kind of only starts appearing once you run a bunch of benchmarks. Like it wasn't obvious that running TPCH benchmarks would kind of influence our go-to-market strategy. It was more like, how do we compare to like a system called Impala at the time, and Spark SQL was in a very early stage, super unreliable, but we were kind of comparing against that. And actually we did pretty well, but we also realized that let's say compared to a Redshift, which was appearing, that there was a huge gap. So that and that was a little bit kind of an unexpected sort of finding in a way. But yeah, that like benchmarking is always sort of a journey. You don't you have a sort of sense of where you want to go, but then you learn about the thing you're measuring, and based on that you start asking other questions, and then you end up in an entirely different place often. I often think of it sort of visually as a sort of landscape where you're walking through, and you cannot cover the whole landscape. You're always covering, you're just walking some kind of path through it of like, yeah, I can look at this and this and this and this, but not everything else. But still, as you walk, you kind of learn more and see the next hill and the next hill. So that's kind of what makes it also fascinating, tedious but fascinating.
You make it sound dreamy and pleasant of a walk.
Well, you have to, because it's super annoying to do. Like you have to sort of motivate yourself, right? Like it's the challenge is often that it's like in terms of the problem space, like benchmarks have this sort of exponential space, right? Like there's maybe thousands of dimensions, variables, like which influence the performance of a system, and you're often just changing one of those, but pretty quickly you might find that you're bottlenecked. Like you're measuring something stupid, like you're measuring the client or something. Something silly happens. And every iteration takes several hours to go through, so you only learn this very, very slowly, and that's kind of part of the frustration. But if you imagine it being nice, it being a nice landscape, then it helps kind of going through with it.
I think that I also don't like running benchmarks. I think that's one thing we definitely have in common, Marco. But one thing I do like is like finding out things that you didn't expect. I think that's doing benchmarks just for sort of the sake of getting the numbers. It's not so much fun. But doing benchmarks and finding out that something you didn't expect is very slow, or actually something is very fast, even though you didn't know. Those things are like sort of the results are nice, but to get there, indeed, it's usually a long and tedious journey.
Maybe I'll chime in and ask Adam's question from the chat. Adam asks, should benchmarks become declarative, fully automated, and reproducible? Bench ops like DevOps, but for benchmarking methodology?
Well, I mean, the obvious answer would be yes, but so I think one of the things you find, like once you start running benchmarks, is like which dimensions matter, and those might not be the dimensions that you expected and had built automation around. And so it's pretty hard. And this can differ for every system, every database system, even for different workloads. So it quite often happens that you build all this sort of nice automation to change all the run different configurations of Postgres, use different disks, using different machine types. But then it turns out that actually we needed multiple driver nodes. Otherwise, we're just measuring the capacity of the driver node. And now I need to go and rebuild my whole sort of benchmarking system to support multiple driver nodes. And that's a lot of work. And the type of work is often very context dependent. Are we starting with are we mostly doing this on one cloud provider, or is it about a database system or a distributed database system or single node or something with read replicas? They all kind of tend to have different requirements. And actually building something good that covers a really broad range of benchmarks for a broad range of systems, it's just extremely hard and perhaps not very economically viable, because it's you cannot easily sell it, right? It's easier to build something that you can sell, because then you can get some money and you can invest it in a product. But with benchmarks, that's often a little bit trickier, because the value is sort of not directly coming out of the benchmark itself.
Yeah, I think everyone that ran benchmarks, almost everyone that's run benchmarks for a significant amount of time, they built their own sort of automation to run the specific benchmarks they needed to run. And then probably they shared it with people, and then no one used it, or I don't know, a few people used it. But then it slowly faded into the past, because the next person needed to run different benchmarks on different types of machines. So stuff gets outdated also very quickly. These kind of things, yeah.
Right. Yeah, I mean, there are attempts to especially for database benchmarking. There's Benchbase, which is a kind of somewhat generic, extensible database benchmarking tool. So and it's kind of built by CMU, the university, but with many maintainers. And hopefully that project keeps going and keeps improving. But it's a lot of work, and someone needs to be willing to put in all that effort to write a good tool for benchmarks, and then keep it up so we can still use it 10 years from now. And that's economically that's often challenging, but technically everyone wants better tools for benchmarking, and also if you're building a cloud platform, ideally at an early stage you already start building some automation around this. But again, you probably have customers asking for things, so are you going to do the thing that the customer asked for, or are you going to build this benchmarking infrastructure that you might only use a few times, as Jelte mentioned? It's the economic choice is difficult. So it usually ends up with a lot of manual labor and kind of very narrow tools that do automation, but for a specific system and set of scenarios.
Okay, so you mentioned Benchbase, and I dropped a link into the chat. One of the things I really want to explore are, from both of you, Jelte and Marco, are links to your favorite resources, blogs, websites, tools, things that helped you either initially learn about how to do effective performance benchmarking, or just gave you that tip that solved that one little problem even after you were an expert at it. What are your pointers? What are your recommendations? Favorite tools? Marco, go first, please.
Yeah, so apart from Benchbase, another tool we I've used a lot in the past, Jelte's used, HammerDB is a pretty nice benchmarking tool for different relational databases. I think they have Oracle, SQL Server, MySQL, Postgres, probably DB2, and then they implement some variant of TPCC and TPCH. And it's a pretty well maintained tool. The code can be.
And it's not a database. Just to be clear to anyone who's listening.
That's a bit confusing about HammerDB. Usually we name databases like if it's DB in the name, you think it's a database, but it's purely a benchmarking tool. It doesn't store your data.
It hammers the databases.
Yeah.
Oh, that makes sense. Okay.
And it's published by the TPC, which is like the Transaction Performance Council, which defines all the sort of the most well-known, most standard benchmarks. And then I think I sort of have a love-hate relationship with sort of TPC TPC benchmarks and TPCH, TPCC. Like, in a way, it has this problem of this is only one specific workload, and it's often a pretty strange workload. Especially, I find TPCH pretty strange because it's just not. It doesn't link very well to the way people usually use their analytics databases. But they are pretty. Usually, most of these TPC benchmarks, they are pretty good ways to stress a system. Like, it's really hard for a database to answer a TPCH query, and it's pretty hard to do all the sort of different TPCC transactions concurrently. So I do like it a lot as a benchmarking tool. I mean, there's obviously yeah.
Okay.
And there's obviously, like, Postgres comes with PG Bench, and I mean, this is a very, like, simplistic benchmarking tool. I mean, you could use it to run your own files, which is kind of neat. But the built-in workloads, they're extremely basic, where they're just always looking up a single row, for example, or updating a single row, which is not, what tends to happen in practice. But again, for studying specific aspects of the system, like it can actually be very nice that you have this very clean benchmark that's only doing one particular thing. So it also depends on, like, what kind of thing are you interested in, what kind of question are you interested in answering, which benchmarking tool kind of makes the most sense.
I think another one is that we use a lot, or used a lot, is YCSB.
Yeah.
It's for really simple queries, basically. It's much closer to many sort of websites that do, like, simple update, simple delete, simple read, and not much else. That's like their main. That's the main. It pretends to be Yahoo. It's like a Yahoo benchmark, basically. So it's like fetching something from, or at least it's made by Yahoo at some point, and yeah, so it just does very simple queries. So but it does a lot of them. So that's why that's what makes it difficult to manage as a database. And apart from that, I think this is all how to run the benchmarks. But that's normally, for me, that's like half of the running the benchmarks. Like the tool that runs the benchmark is like half of it. Like, the rest is creating machines, setting them up in a way that you want to measure. So it's much more like managing the database itself, and simply and easily being able to spawn that, and setting up a machine with this database benchmark on it. So there's many tools to do this, but it really depends where you want to benchmark as well. If you want to, for instance, benchmark VMs against Kubernetes or something, you can't use the Kubernetes stuff for the VMs. You have to use the Terraform or ARM templates or CloudFormation, some of those, to sort of create the infrastructure to be able to run your benchmarks. And if you're using, like, actual bare metal, then it's even harder. Or you set it up once, and then you need to do some of your own automation, maybe with even some other tools. So it's comparing things, and setting up the system itself is already a big task, usually, when doing benchmarks.
Jelte, you're saying that for the setup part, it sounds like you're saying always use a declarative tool in any case.
Yes, yeah, you don't want to, because I think that's one of the main things I learned, at least, is, like, your first benchmark your first 5 runs, they're going to be wrong. You messed up something. That's you configured something incorrectly, and so you have to redo it. You have to redo them. So you need to have an easy way to recreate sort of the system that you had, because you're going to do it 5 times anyway. That's my sort of my rule of thumb.
I remember reviewing a blog post that you wrote sometime last year, and it was about, I'll go look up the link in a second, but it was about how to benchmark performance, right, of Postgres using HammerDB. You were running it on Azure. And I remember reviewing the draft, and like the first sentence had like multiple exclamation marks with like, your main advice to anybody running benchmarks is automate it, right? That
Yeah, that's still my main advice. I think that's like the only way to not go crazy when doing benchmarks. Because otherwise, every time something goes wrong, you're like, no, and if you automated it, at least it's like, okay, well, I just press a button, I wait another day or another few hours, instead of having to reset up the whole machines, or yeah.
Yeah, I think that the earlier you automate, like the less regret you'll have later on. Even if you like want to know the results sooner, like it's probably better to spend a little bit more time on automating. I think that's maybe one thing that has improved over the years. I remember especially doing the TPCH stuff a long time ago inside of Zeta. It was all kind of CloudFormation based, and it's at the time CloudFormation was especially tedious in terms of syntax, and it like actually testing the template took like usually an hour as well. So it's kind of hard to debug these automation tools, but still, like you'll regret it later if you don't spend a good bit of time on that first. And the other thing that's important in terms of tooling is just like any kind of introspection. I mean, in a way, like the most important thing in benchmarking is to sort of understand what you measured. Like you get a result, but there's no way of knowing what a certain queries per second means if you don't have like additional data and clues to back up, to build some kind of mental model of like, why am I getting this result? So like profiling tools are kind of useful for can be useful, but you also want to sort of collect a lot of metrics on how much I/O is the system doing, like using things like I/O stat, how much CPU, and because it's pretty much always happens. I would say like 99% of the time, there's a point where you realize you were just measuring the performance of the client, not the performance of the system under test. I mean, that happens a lot. And so it's good to gather a lot of metrics through various tools to have at least a mental model of like what's going on when you run the benchmark.
And when you say profiling tools, what are you specifically talking about?
I mean, we worked a lot with Perf. It's a pretty nice tool on Linux that can kind of give you sort of I mean, one way to use it is to kind of generate this flame graph of where the CPU spends its time in different functions of your program. So that gives you a kind of good sense of what's actually happening, and it can also be very helpful for performance optimization. If you, I mean, that can be a reason to run a benchmark. Is like, I want my system to be faster. Then you run the benchmark, but then at the same time you run tools like Perf to see what is the system actually doing, where is it spending most of its time, and then you might see that there's like one function that's just like copying a lot of memory around, for example. So that's quite an important tool. But I think it depends a bit on the language. If like you're benchmarking software in Go or Java, there be other profiling tools.
But in the end, most of them are able to generate flame graphs. So it's not so much. I wouldn't say it's so much the tool itself that matters. It's more like the output of the tool in this case. A flame graph is really useful, like a general sort of perf report on functions, like how much time is spent in what function can also be fine. But those kind of things are very useful.
Any other profiling favorite types of visualizations or tools, or I don't know, even like conceptual resources, like the book you read when you were 25 years old that really helped you understand that whole space of introspection? I'm just looking for tips for someone who is not yet an expert the way you both are with benchmarking, but wants to be. How do they get
I,
there?
I would say one of the most important things is even before you do perf. I think good to reiterate, sort of Marco mentioned it a bit, is to get metrics of everything, because usually there's one thing that's the bottleneck. It's like either you're using all your disk, either you're using all of your CPU, and then if you're profiling the wrong thing, you're just wasting your time, because if CPU is the bottleneck and you're looking at, let's see how many disk updates this thing does. I mean, it's not gonna matter if you improve that at all. So it's first important to find out what the bottleneck is, usually, and then get a performance report of that, a flame graph or some IO IO statistics, something like that, to find out how you can improve the final performance. Because that's when you're doing these kind of things, that's what you want to do. You have some performance at the start, and you want to have a higher number at the end.
What are you using for plotting and graphing? Is that built into some of the tools you mentioned, or do you use something else?
I use HTOP a lot, like sort of task manager, or basically like just shows if CPUs are busy or if IO is busy, or what processes are doing a lot. So I just sort of general look at my computer and see what it is doing. That's one thing. And usually I do benchmarks in Azure, and there, like there's metrics on the, like, it tracks metrics from the machine itself, like how much IO operations, IOPS it is doing and it's allowed to do, and how much bandwidth it's allowed, network and disk, and how much CPU it's using. So you can, if like one of those graphs is like at 100%, well, you almost certainly found your bottleneck. That's the thing you should improve.
And are there tools to save data of successive runs, or is that something you just have to sort of self-organize? What do you capture from every run, from every iteration?
In general, that's something you have to self-organize, at least in my experience. There's some. I think HammerDB, for instance, it can take some metrics sort of from the database itself and save those automatically. But like I said before, like the thing you're running it on is also a big part of your benchmark. And that changes. So like it's a thing you're running, it's a benchmark you're running, and the thing you're running it on. So this combination of things is so large that there's not really good tooling around it, at least not for everything. Mm-hmm. You have to, yeah.
So I just want to point out that relating to what you were just saying, Jelte, while you were talking, Marco dropped a link to a webpage that Brendan Gregg built out that has links to documentation and articles and presentations that he's given on performance. So I just want to, for anyone who's never heard of Brendan Gregg, he originally worked at Sun Microsystems, which is probably back when I first met him ages ago. And he is just well known in Linux for having done a lot of work on performance. So anyway, I'm looking at that webpage right now, and it does look super useful for anyone who wants to kind of spin up and learn a lot more in this space. And there's a lot of YouTube videos here as well, as Melanie points out. So I'm curious.
Definitely brandongregg.com is like, when you get really deep into performance benchmarking, like this is the resource. And he's probably like the world's leading expert on this topic. He has some books I see now, so maybe I should get those, because Pretty much all the content on there, it's deeply technical, but sometimes it can be a lifesaver. I mean, we've had this sort of locking issue in the past where like we ended up generating these what's called here off CPU flame graphs, and there's like a description on his website of how to get those, and that made us realize that it was in fact a locking issue. Yeah, like it also describes how to make flame graphs, how to use advanced tools like eBPF and other things like perf. So yeah, that's definitely the resource, especially for kind of more advanced performance studies. I've never found a better website than that.
Even for simple performance studies, I think it's very good because it has all kinds of perf commands that you can just copy paste and they do the thing that you want it to do. Because like the flags to perf, they're not something I can remember.
Yeah, true. Yeah, and there's also some aspect of benchmarking where it's you need to build up a sort of a mental model of the system and how it behaves and what it does, again, to kind of understand why you're getting a particular results. Right, like for example, for database workloads, one important, very hidden variable that's not really there's nowhere where you can see it. You just have to sort of imagine it being there. Is the size of the working set, and when we say size of the working set, it's like, you know, what is the part of your data that's very actively queried and therefore typically cached in memory? I mean, if that's larger than your memory, then you're going to suddenly do a lot more I/O, which is going to sort of make your results a lot worse, probably because I/O is slower than memory. But there isn't a specific way of measuring a working set, or like it's not really a number. It's more of a pattern, a sort of distribution. Yeah, it's I've not seen like super good tools for those kind of things. It helps to have a little bit of an intuition of like, hey, there is this thing called the working set, and if my benchmark workload involves querying every key in the table, and the table is super huge, bigger than my memory, then probably this working set thing is going to be an issue. Whereas if the workload is more kind of concentrated on a small number of keys, a small amount of data, then it's going to be more of an in-memory workload. So that's also one of the hard things about benchmarking, that there's like these hidden parameters, hidden metrics that aren't actually very easy to measure, but can be extremely important.
You know, I realized that in this conversation, I've been asking all my questions of you, Marco, and you, Yelta. But Pino, you've done engineering for years and years and years and years. I'm curious, did you ever work on performance benchmarking?
Oh gosh, I've got to admit, I probably got out of it by pushing it to people who liked it more than I did or disliked it less than I did. I'm trying to think of very early on, I might have done some benchmarks, but very rudimentary, and it's lost to memory now. But I was going to ask, you know, that in that regard, that many people coming to benchmarks are probably looking, you know, coming at it as developers that have other components in their system beyond the database. And I was wondering if Yelta or Marco have advice about, you know, what should we be benchmarking? What should a developer be benchmarking? The whole system, breaking it into components right away? Any advice about that?
Like an application developer that uses a database, right?
Right. Yes.
I think in general, what's sort of the recommended approach then is to find out what sort of your most used queries are, or the queries that you know are currently very slow, because that's and then benchmark those. So you have a few important queries that you care about, because any website is going to do. There's some admin interface that there's some query that you don't really care about. It's a bit slow or a bit fast, or it's never run, so it doesn't matter. But there's a few that are either so slow that they break the whole system, or that you run so often that any small improvement there is going to make everything else also measurably faster. So generally, it's sort of those are the queries you wanna test. So your whole system, it's possible, but it's then you have to sort of make your own benchmark suite out of your system, and it's much easier to, if you have a few queries, to use those queries in, for instance, pgbench to sort of simulate your system a little bit, like the important parts of your system.
Right, that makes sense, because you'd be throwing away all the standard tools if you were just testing your API or your website, and right.
Yeah, I mean, you can also do like sort of full, like it depends if you want to benchmark your database or your actual website also. If you sort of know where the bottleneck is, then you can, if you know the bottleneck is in the database, then you can just do the queries. Otherwise, you might actually want indeed to sort of send many HTTP requests to like a staging environment and see what your own system is doing.
So Yelta, is there a tool that can look at the application and help create or simulate workloads, right, for your performance benchmarking that are close to the actual application's workload? And I'm literally quoting a question from Bilal in the chat that seems relevant to this thread. Do you know of such a tool?
I think there might be some proxy layers that sort of detect what web pages get visited often, or like what patterns get visited often. But in general, you don't really need to benchmark the things that happen often, and most of the time you already sort of know which those are, or at least it's fairly simple to look up if you have any kind of metrics or logs on your website or your database. And then you can use those to create a list of things to put in sort of a generic sort of load tester application for Postgres. That's pgbench. For your website, that's, I mean, it's been a while since I did, but when I did it was WRK. I think was the sort of the thing to use back then. But that's, I mean, those things change. But like, give it a few URLs and just make it to send requests to those many times and as quickly as possible, and see what kind of breaks, or then profile your system to see where it's spending time.
Okay.
And I guess I also wanted to address, Marco, go ahead and chime in if that.
Yeah, I was going to say I've not seen great tools for Postgres specifically in this area. I mean, some of the commercial vendors, or SQL Server, Oracle, they tend to have decent tools for kind of workload replay, where you kind of capture a workload and then sort of try to amplify it by until your system is fully loaded, so you have some good sense of how far you can scale on your current hardware. I mean, there's definitely some open source tools out there as well. But yeah, it's also, I guess we've also often have been in this situation of a database engineer, right? So you don't care about one specific workload. You care about all workloads, and you're trying to find sort of somewhat generic representative things. But yeah, as an application developer, it's useful to have such a replay tool. But in lieu of that, like as Yelta said, like if you can find the core piece of your workload, I mean, the other 70 things that your application does probably don't matter that much. Like it's this 100,000 selects per second plus this large update that you're doing that's probably going to dominate the work.
What about when? Any advice about when is the right time to benchmark? Often it's, we're about to launch, so we better benchmark and make sure we won't fall over. Or we need to scale up, and maybe it's going to start costing too much. But any advice about benchmarking that's not quite as reactive?
I mean, it depends on what kind of there's not one thing to achieve with benchmarking. There's like a variety of things, as we've already gone over. I want to know how much capacity I have left once, or I want to sort of define my product strategy, or of course, like one conventional recurring thing is like releasing new software, for example. I mean, that's a good place where, let's say with Citus as a project, but also Postgres, like before finalizing the release, there's like a ton of benchmarks that are kind of done in an automated way to compare different versions. And maybe that's a good segue into, like, it was brought up in the chat, like Mark Callahan, who's on Twitter, has been enormously helpful resource in terms of database performance benchmarking. He spends a lot of his time running benchmarks on different versions of Postgres, of MySQL, kind of seeing whether there's regressions, improvements, testing specific patches sometimes, and testing it in different ways, different angles. And so that's an enormously helpful thing for the whole community, that we can see that when things are getting slower. And software projects, like database software projects, they the bigger ones, they have to have some kind of automated benchmarking infrastructure. That's usually, especially around the release, sometimes even like much more frequent than that. Because in that case, the question is, did we regress on performance? Because it's easy to make a small code change that actually makes everything slower, but all your unit tests, all your regression tests pass, but actually the system is now slower. But yeah, it depends a lot on what kind of question you want answered and when you want that question answered.
I know I've learned a lot in my career by following some key people on Twitter, and I know plenty of engineers who follow Mark Callahan. So if you're listening and you don't know him, it's Mark Callahan DB is his username on Twitter, and there's a G in the Callahan and 2 L's. So you can find it with a search now. Super, super useful. And he shares a lot, right? Which goes back to that first podcast topic that you and Simon Willison talked about, Marco, which is like working in public. I really appreciate people who do share their epiphanies and their learnings and their observations, because the rest of us can benefit.
Yeah, no, I definitely recommend checking that out, because, or just following, because you'll get a stream of very interesting, very useful information about different kinds of database software over time. Even if you're not a database engineer, it's actually very interesting.
So when you talked about, I want to release new software and make sure I don't regress, I mean, that kind of brings up the whole question of, how does benchmarking fit into your software release workflows, and CI workflows? What are your thoughts on that beyond what you just said? Is there more to it? Is this a whole rabbit hole in itself?
Yeah, I think benchmarking is by definition a rabbit hole, because of, again, like the number of dimensions is so large, you can only study a very small space. And it's very easy to, like, okay, we run all these transactional and analytical benchmarks, and we feel like we've captured like a spectrum of sorts. But actually, I don't know, maybe the large batch updates suddenly became very slow. And I mean, there's very few benchmarking tools that try to do large batch updates. So it's pretty easy to have these blind spots. So it's definitely important that you have this kind of suite of tools, and also like not look at one configuration of the system, but at least try several. And again, it's like it's a super tiny amount of data out of like this enormously multidimensional space that you're trying to understand. But yeah, and having that automated is pretty essential. So yeah, I think typically with Citus, if we did a release, there was this whole suite of different tools that ran. But it's definitely not as comprehensive as I would have liked it. I think also in the space, like Citus is used a lot for real-time analytics. and there's no good real-time analytics benchmarks, so it's sort of a little bit of a blind spot, and you end up doing a lot of manual testing to make sure that things haven't slowed down. But yeah, I mean, it's you can always improve it more, and what you can actually measure is in a way deeply unsatisfying. It's like, okay, I've done a lot of work and I've measured like 5 workloads out of billions of possible workloads, but it's nonetheless important.
I have this vague memory from when I worked in the kernel group at Sun, and I should have corroborated this with someone like Brian before today's podcast, but it basically it went like this. If someone was integrating a feature into the kernel and it introduced additional work that was going to negatively impact performance in some way, but it was a trade-off we had to make. Like, we had to introduce that capability, so we were going to have to take the hit and accept that performance degradation. The deal was you had to go make a performance improvement somewhere else to try to make it a zero-sum game, if you will. Like, okay, we're gonna give this up, but we're gonna give you this instead. Is that something you've ever seen before? Is it possible that my memory is valid?
It's definitely a thing. Like, I think more recently, also in Python, they had sort of similar. Like, so someone was trying to do a similar thing. They were trying to make Python better for multi-threaded workloads, and sort of to make up for the loss in performance because of on single-threaded workloads, they added a ton of performance improvements that would make up for like the 10-20% loss in performance because of extra syncing, like atomic operations and stuff like that, and locks that need to be taken. And I'm not sure if that actually. I think for Python, I think the thing that happened might have been that they sort of just took the performance improvements and then didn't take the multi-threading, or at least not yet. Because that's also possible. Even if everyone has to agree that the feature is worth sort of the performance loss, I guess.
Right. Well, what's that quote that you gave the other day, Marco, that I like so much in your PG-COMFY talk in Prague on distributed systems?
I think it's, if you get something nice, you'll probably have to give up something nice. That's often the case in distributed systems, although it does apply to computer systems in general. That very few things actually come for free. So, there's often, for example, also in databases, like a balance between reads and writes, right? Like, you can make your reads a bit faster by doing a little bit more work on the write side, but now your writes are slower. So it's like, what is the right trade-off there? And then, you could add some kind of dial that users can control it, but now you have a dial, which is annoying. Like, now you have to configure the system. It's more complex. So yeah, that often comes in with the issue of performance, that you have to make your system design particular trade-offs.
All right, so what are the other big challenges of performance benchmarking? I mean, you've talked about a few, so maybe enumerate the ones we've talked about already, and then have we missed any? Are there any we haven't gone down the rabbit hole on?
I think sort of the list that we had so far is figure out what to benchmark from the whole space of benchmarking. Figure out sort of what you want to get from this benchmark, because even at the start, sometimes you don't even know.
What's the question?
You start with one idea, and it's not actually the reason why you end up benchmarking in the end. And then, like, the one is sort of automating it, like setting up the system, choosing everything and configuring it, and making sure you didn't configure it wrong, because that happens all the time. Did I miss anything, Marco?
Is that Yelta? Is that repeatability, or is that separate from?
Let's get through the list. I want to get it all together. Figure out what to benchmark. Figure out what you want to get. What's the question? Automating and configuring. What else?
Yeah, so I think yeah, I mean, we talked about like the thing you're running on, like the hardware, where like there's a certain amount of variability often in the hardware, especially in cloud environments, and like you need to sort of accept that in some ways, try to measure it, and so that's a challenge. And then yeah, the sheer number of variables of dimensions that matter, and the fact that you don't know those dimensions up front, and you cannot always easily know, like put a number to those dimensions, like the working set issue. And partly like in benchmarking, you're figuring out which dimensions matter as you go along. So that process makes it quite challenging, at least very time consuming, because you don't know what you're gonna find at the start.
I think one final one is when to stop, because
That's a very good one.
You can continue forever. It's every time you find something new, you're like, oh, now I can do this thing. Now we can see if this is faster or this is slower. It's you sort of have to time box, or I mean, the one way to time box is just until you really don't want to anymore. That's usually when I stop with benchmarking. It's like a hard stop. Like, oh no, I don't want to do this for the next 2 months at least.
So in the chat, some folks have contributed the idea that if you're benchmarking on cloud infrastructure, the hardware can change underneath you. Any advice about that? And is that one?
It's an issue. It's cloud infrastructure, especially. It's like very variable in performance in general. So the only way sort of to work around that a bit is just running a lot of benchmarks, like running a handful, and then hoping the difference is large enough that it's obvious that one is better than the other. Like,
I have a challenge.
sort of finding sort of the bell curve, and then seeing like, oh, this peak is clearly much higher, like more to the right than the other.
Mm-hmm.
That's the only real way I've been able to do it. But it is time consuming, and it costs more money because you have to run the same benchmark over and over again.
I want to add a challenge, which may be bigger for some people versus others. Like, it all depends on your communication skills. But I feel like when you've run on these performance benchmarks, you have to then turn around and explain the conclusions, right, to your team. Some of whom may not be technologists, some of whom may not, especially if you're trying to influence the product strategy with it, right, or the go-to-market strategy or whatever. Someone's got to interpret all those charts. Someone's got to decide what are the right charts to share of these bazillions of iterations that I've run. Is that a challenge, or does that just come naturally to both of you?
It is a bit of a challenge, because you kind of like, by the time you're done, at least it's also, you kind of want to show everything, because you're like, I spent so much time on this, I did so many benchmarks, I want to show all the benchmarks I did. But then you sort of miss the point of the benchmark in the end. So it is, it doesn't come supernatural, but it's. Once you see like, oh, if a graph with like 20 bars, it's obvious that that's not really tenable. You have to sort of filter out the ones that don't really add much. But yeah, that does feel painful, because you spend so much time getting all this data. But in the end, sort of this time is really spent finding out what bars are important, what data points are the ones that you care about now, but didn't know you would care about before the benchmarks.
All right.
Yeah, and I think part of the challenge with the sharing and like is the storytelling, and that you don't know the story up front. But sometimes when a clear picture emerges in terms of, the bigger stories are, how do two competing systems compare, for example. But you just need to be very careful in those stories, because you need to be very, very confident. Like, there's also like a confidence interval, right? Like, if you think the system slowed down between versions, but actually it was, your cloud hardware, just you were a bit unlucky and you kept getting slower machines at a particular time of day, that happens. But you can afford to be wrong. But like for some of the bigger stories, like determining your go-to market strategy, you cannot really afford to be wrong. So it's often like there's often a lot of confidence building you try to do when you run benchmarks of like, even running the same thing at different times of day. We've seen that matters in cloud environments. Strangely enough, especially for distributed systems, because the network gets more loaded in certain times of day. Then again, it's also when do you stop? Like, you can always try to become more confident, but at some point you need to stop and tell a story and then hope you're right.
Melanie Plagueman in the chat is wondering if either of you want to start a benchmarking support group.
That sounds like a good idea.
Performance Testers Anonymous is Jeremy's proposed name. So
Yeah, I would definitely join that.
Okay,
yeah,
so
and I know a few other people who will instantly join that.
all right, it looks like you've already got a group of 10 to get started. Marco, I know last year there was a third-party comparative performance benchmark comparing several different databases against each other that was published. I'm just curious, do you want to talk a little bit about why companies will hire third parties to run those kind of performance benchmarks when they want to publish them, like when they want to make the results available to customers and prospects and such?
Right. I guess one of the reasons is like you cannot trust the vendors, right? Like the vendor will continue like tweaking their system until they're the fastest. So every vendor published benchmark ever will show the same kind of result. Like our bar is bigger than the other bar. But so involving the third party, they can bring a particular type of fairness in the choice of setup and kind of almost also how much time they spend, on tweaking the system and those kind of aspects. So yeah, it's a little bit more objective, but of course they're also often more simplistic in a way. Like it's a single. Often these comparisons have a single workload on a single setup, and then one bar will be higher than another bar, but it could be that if you had used a different workload or had used a different setup, it might have been different. So, but like you kind of also have to sort of interpret. Like in this case, it was a comparison between Cosmos PG and GrokRoachDB and Yugabyte on the sort of HammerDB TPCC benchmark, and like the difference in that workload is quite huge. So it's not just a setup thing. Like if you can tweak the systems in different ways and enable HA, disable HA, have more memory for one system or less, like change some settings, but like the difference is actually a little bit too big for any of those things to matter. But of course it says nothing about say analytics performance, so you have to also interpret like, is this relevant to my workload? And then I think TPCC again, it's simplistic, not representative of a specific workload, but it does stress transactional systems in a pretty good way. Like it gives it a lot of complex work to do, so that's kind of nice. But yeah, you always have to like read it with your own interpretation.
So as we've meandered around the performance benchmarking topic in the last hour, did any other stories come to mind that that Pino and I haven't asked you all about, in terms of your experiences benchmarking, your big epiphanies and lessons learned, your big screw ups, your failures, like the mistake you want to make sure anybody listening to this podcast doesn't have to go through themselves?
I think one super simple thing is make sure your driver, like the thing that's running the benchmark, is running like a modern operating system. Because in like one benchmark I did, at some point we figured out that the benchmark node, not the one with the database, but the one with the benchmarking suite, is using some old version of OpenSSL, and that was so slow that it would slow down the benchmark so much, without actually without actually seeing that in like CPU statistics or something like that. There was some locking issues there. But yeah, make sure that at least the systems you're running on, they have modern software on them, because otherwise you're just going to run into the same performance issues that other people have already solved.
Can you define what a modern operating system means to you?
If you run on Red Hat, only the newest Red Hat, that's for sure. Not the one that was released 5 years ago and already had outdated software back then.
Okay,
But
so
yeah, like Ubuntu, or but also not like the oldest LTS of Ubuntu. Just like the newest release of the OS you care about. I think that's the sort of the short version.
okay, got it. Marco, any failures you've experienced you want to warn someone else about?
Well, I know there's something that comes to mind where it's very specific, so I don't know if it's a good general warning, but it's just a frustration I have that sometimes you just cannot figure it out, and so Citus has this feature like where you can query from any node, so the client can connect to some random node and then it does an insert or something, and maybe the shard for that insert is on the same node, maybe it's on a different node. And so if it's on a different node, it'll make a connection and send the insert over there. And so in principle, this scales to very high throughputs. And so a weird thing happens when we we've seen this weird thing happening when we benchmark it over and over again, that like we put a lot of load on the system, but the utilization actually kind of goes to like 70-80% instead of like moving to 100. And my theory is like there's this thing going on where if a node gets a little bit too hot, the rate at which it starts offering work to other nodes kind of slows down as well, and therefore kind of the system internally sort of slows itself down again. So you get into this equilibrium at around 80% utilization. And so we're not bottlenecked at anything. It's just like it just stops there. And so it's like I've never truly been able to figure out and understand why this happens. It's not necessarily bad because it's sort of self-regulating and like you don't hit super long queues and super spiky response times. It's actually a sort of nice property, but I have no clue why it happens. And I've run this like a lot of benchmarks on this. But yeah, still one day hope to figure out why. Like what are the mechanics behind that? But yeah, sometimes it's just extremely hard to understand why you get a particular result.
You were going to talk about how important it is to sometimes step away from your desk and get outside, go hiking by the canals, and take a break, and then you have the epiphany and you figure it out. But you haven't figured it out yet in this case.
Yeah, we're still waiting for this epiphany. But I mean, that's good advice. Like just and in general, I feel like an important thing in benchmarking is just really like doing a lot of thinking and understanding like why would I get this result? Like why if I change this variable, I don't know, some silly thing like workmem. Like why do I actually get better results if I have, let's say, a lower workmem? I mean, the can be curious and at least I mean one thing I enjoy, but it's also really hard, is like just trying to understand those things and figure those out, and then if you can figure it out, you also know why you got a particular result and you have confidence in your result, you can share it. So in a way that's the sort of like sort of hidden goal of benchmarking, where the first goal is you run the thing and you get the numbers, but there's the second goal of like actually understanding the system very well, and that's kind of what's enjoyable about it, but also what's sometimes frustrating about it because you cannot always understand it.
So you get something good, which is the understanding of the system, but you have to give up something good, which I don't know, somehow relates to frustration. I'm trying to make a connection to your great
You
quote
have
about
to
distributed systems. And
you have to give up an awful lot of time. Like this is one of the most time consuming and hardest thing in database development to me. It's like, sometimes you can be doing this for weeks or months even. So that's definitely a big nice thing you have to give up.
but it totally changed your life, Marco. I mean, when you think
Definitely,
about it,
yeah. I got a lot of nice things back. Like I gave up a lot of nice things and I got a lot of nice things back.
yeah, it changed your career path. It changed your the path of who you spend your time with in your life. I mean, going back to your AWS part-time CloudFront performance benchmarking job that you did while you were getting your PhD. Like,
Yeah. Maybe I should do more benchmarking. It's no, I mean it's definitely it's an important thing and it's hard to measure the impact, but it can be, it can be more impactful and often is more impactful than actually writing code and like adding features to your product. Although it's hard to know that upfront. You'll only know in hindsight years later.
all right. Pino, any final questions before we wrap up?
I don't have any final questions, but I've really enjoyed this conversation. It's been great.
I'm seeing something in the chat that I just want to add to the voice conversation, which is Melanie's tip of always checking the logs. I don't know if you guys can see that comment, but she said, one time I was benchmarking a patch and couldn't figure out why it was slower until I realized it was emitting extra warnings because of a mistake in my patch, and emitting the warnings was affecting the performance. So, um, I think we would all agree that checking the logs is a thing that people do and should
Yeah.
do, and good to remind oneself. Okay, Delta, Marco, thank you both very much for joining us. This has been an awesome conversation. I've really enjoyed it, and I'm sure a lot of people out there will too.
Right. Yeah, it's been great. And like until until my next appearance, I don't know when, but this was a lot of fun.
Yeah, I had a great time.
The next episode of this podcast is going to be recorded live on Wednesday, February 7th at 10 a.m. PST. Also on Discord. The guests and topics are still TBD. One of the guests is already confirmed, but we're still working on lining up second guests. So that'll get announced soon. You can mark your calendar by if you want to reserve the time right now with this short URL, aka.ms/path to CitusCon, all one word, -EP12-cal, CAL. You can get to past episodes and links to all the platforms where you can listen to this podcast at aka.ms/path to CitusCon, all one word. And you can find transcripts on the episode pages on Transistor too.
We'd also like to ask you a favor, especially if you've enjoyed this podcast. Please rate and review us on your favorite podcast platform. That helps other folks find this new show. And a big thank you to everyone who joined the recording live today and participated in the live text chat on Discord. It was fun.
Thank you. Ciao, ciao.